So exam 2 is due tonight, and I just now posted the other part of review 2 on Canvas. So the video meeting from last week is up there. Both parts of the review are up. Okay, any questions about the test? Okay. So we are on our third and final topic, and exam 3 is only on this topic. So there's no final cumulative exam, just exam 3.
Looking ahead, will the not the final exam, but our final exam, which will happen, which will be kind of like a final. Will that happen during finals week or the week before?
I think it would be good to do it the week before, and that way, in case there's any issue, there is finals week to finish things up. So we'll try to make it early. So me.
Okay, cool.
That's a good question. Okay, this is week 11, 12, 13, 14, 15. So I'll probably have it posted at the end of this month and then due at the beginning of next month, and that way there's time during finals week just in case. Okay, so today is focusing on what a graph is and a lot of examples. Okay, first, what this graph isn't. This is not the same kind of graph that is in an algebra class. So it's not the same as the graph of a function. Okay. So the graph of a function is a set of points, but what we're talking about is a collection of dots and lines and relationships between the dots, which is formed by the lines. So the first part for, let me see, I think this is chapter 5, but we'll get to that later. I'll bring that up next class, what chapter we're in. So the dots are called vertices. So vertices is plural. One of them is called a vertex. So a single is a vertex. A couple of dots are called vertices. And the lines, they don't have to be straight lines, but the lines connecting the dots are called edges. And a graph is a collection of vertices, and they are connected by edges. edges connecting vertices. All right, we're going to do an example like this. So we'll call this graph number 1. This is vertex A. And over here is vertex B. And there's an edge, which we call AB. This is going to connect them with this line right here. So first, let's list the vertices A and B. And there's one edge, AB, which is the same as BA. Maybe closer together. It's like a pair. So before we do more examples, a edge needs to go from a vertex to a vertex. So each dot needs to connect to the line. You don't want to have a missing spot right there. It needs to meet and show that there's a relationship between A and B. Number 2. Cool. So this graph has, so with a sort of, it's a triangle with an extra poke like this, like dots that form a triangle. And A, B, C, D. So we're listing vertices and edges, and that's the goal for the rest of class. So it's these dots here, A, B, C, D. They don't have to be in order, just separate them. And we want to list each edge, but no repeats. So there's edge AB, and then BC, CD, DB. C, C to D. D to B. And then we're done. If we keep looking, we'll have repeats. BA is the same as AB. 1, 2, 3, 4. 1, 2, 3, 4. So we're going to do graph number 3. It's a crisscross like this. Dot to dot to dot. Over, over, over. we will have 1, 2, 3, 4, 5 vertices and 1, 2, 3, 4 edges. Labels are H, G, J. This is I, and that's T. Okay, so we need H, G, I, T, J. Oh, that's the vertices. That's okay, those were vertices, and now we're doing edges. So I want to mention that we go from dot to dot. So there's HI, but we're not including HJ. That's not one of our edges. So HI, GI, JI, TI. Here. JI. And TI or IT, either way. 1, 2, 3, 4.
How come we don't do the combination of lines? Like GT and HG, or HJ and GT.
H, J.
So like we did like I saw that we did the mine like the smaller one, so from out into the middle. But then what about doing like the ones that go from, I guess you'd call it side to side. So we did all of them that go to I, but then how come we don't do GT and HJ?
It's a rule for this section, so we'll write it down. But kind of like you said, we're going to go from dot to dot or vertex to vertex. So let's write down. So it's like a rule for this section that a edge needs to go from a vertex to another vertex. And as a side note, which will kind of come up later, I'm sure, we can draw the same graph, but a little bit different. It still shows all of the same relationships, but I can start with the center and have I in the middle. And as long as I goes to H, we can have J go kind of this way. But we still need I to G, which we could put over here. And then we could put T up here. Or maybe like more like a star. So this is the same graph as graph number 3. So that way, like something like HJ is more clear to not be an edge, but H to I and then I to J.
That makes more sense. Thank you.
Yeah, we have a lot of different fun things to practice, but today we're just gonna get used to the dots and connecting. Okay, so number 4. This time there is a triangle, dots, that. We're going to cross over one of the edges, but there is no dot. It's just an overlap. Cool. M, D, S, R. So edges go from vertex to vertex, and there's no vertex right there. Let's do the vertex first. Cool. R, S, and D. The edges will do down here. So sometimes I like to pick a vertex, find all the edges that come off of it, and then go to the next vertex, find all of its edges, make sure you don't get any repeats, and then keep going until you've checked every dot. So I'm going to start here, SM, SR, SD. And that's everything. Cool. There's MS, which is the same as SM. M to R, we need. And that's all. Okay, we did DS. And RS is listed, so is MR, so we're done. And also in this situation, we could count. There's 1, 2, 3, 4 edges, and I've got 1, 2, 3, 4 in my list. Okay. So just, if you're still writing down, it's SM, the next one is SR, after that's SD, and MR. I think we'll be able to draw this together. So we're going to have a dot and up, dot, loop, dot, dot, over, dot, and like this. Starting on this side, R, F, K, N. This one is Z, and that's T. Okay, edges. So R, F, K. Oh, I'm sorry. I keep mixing this up. We're doing the dots first, which is vertices. Vertices, dots. Okay, R, F, K, N. CT. Let's put the edges in this corner over here. So there's RF. There's a connection between those vertices. And then we're going to have F to K. K goes to N. And there's a connection between N and T. Also, there's N with C. That should be everything. Okay. I've got 2 more examples. So number 6. By the way, we'd call this graph number, that was graph number 5. So we're going to work on graph number 6. So with the star, I'm going to go down, down, over, over. Starting here with A, B, C, D, E. Okay, let me see. Vertices are the dots. Which is A, C, B, D, E. And the edges are the lines, or all of the relationships that are between the dots. Let me start here. There's A, D, A, E. C, B, C, E. D, A, we already have that one at the top. D, B. E, C is in the list. E to A is right there. And then B to C, we have that one. B, D. Just a quick check. There's 1, 2, 3, 4, 5. I found 5 edges. There's 1, 2, 3, 4, 5 lines.
Professor, I got a question.
Yeah.
So I know you said, I forgot which exact example you said this, but you said, I remember you said like vertices, the number of vertices don't reflect how many edges there will be. Like those numbers don't necessarily correspond. However, did you say that when you're determining the number of edges or what the edges are, the number of edges correspond to the number of points on the graph? I thought you said something like that, or I could have just totally imagined that, but I thought you said something about one of the aspects correspond.
I might have, but it turns out that that is actually going to come up soon, and we can talk about it a little bit right now. But there is a relationship between the degree, which is the number of lines connecting to the dot, and the number of edges which you'll have. So this will be in the future, but just as a preview. So we're going to talk about degree in another class, like later on. That's how many lines meet the dot. So this one has degree 2 with 2 lines. This has degree 2 with 2 lines connect to that dot. Same here. 2 lines go there, 2 lines, 2 lines. And we take the sum of the degrees and divide by 2. And that's how many edges there are. So this is going to be, coming soon. But right now that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 2, and you get 5 edges. So I won't write that down because we'll go over it later, but I'll say it one more time. If you divide the sum of the degrees by 2, you can have the number of edges. Okay, one more example, but we're just practicing vertices and edges. Before we do that though, when I do the quick check, all I'm saying is if my list looks at least like it has enough or not too many lines as my picture, but I didn't actually check if the list was correct. I was just making sure I didn't miss anything or overcount. But when I grade your homework or exam, I will be checking exactly what connections are written down and how many of them are written down. Okay, let's do one more and call it good. Number 7. So we've got A, B, C, D as a diamond. We're going to go over, and then we're going to go kind of bent like that. Oops. Okay. E. Oh, I'm missing a piece. We're going to go C to E to G, and then over here, which is going to be F. Right. The vertices are the dots. Which is A, B, D, F. C, E, G. And then we're doing edges that are A, B, and they'll have A, D. B, C. We already have BA, but we're going to list the next. Okay, C goes to B, but we just did that one. C goes to D, and C goes to E. Let's go this way. There's E, which goes to C, but we just did that one. E also goes to G. E to G. Okay, G to E, did it. G to F. And then, let's see, did we get FG and FD? And then let's see, we have D to F, we have D to C, and D to A is right there. And then we're back at the beginning. So I should have gotten all of the lines. Quick check would just be to count like visually. There's 1, 2, 3, 4, 5, 6, 7, 8. My list has 1, 2, 3, 4, 5, 6, 7, 8. But also that list needs to be accurate. So nothing in the list like DE. That's not an edge. And one more thing I want to say for today's class. Okay, this is not a graph. If you have a vertex and just a line and there's no dot at the end, then it's not a relationship between two vertices, so it's not going to be a graph. So what we're trying to do is show relationships between things, and the things are those dots right there. Okay, that's the end for today. So again, your test is due tonight, and we'll work on graph theory for the rest of the semester. Thank you, everybody. Let's get this.